Since we're quiet, we're here, we're prepared, we're ready to rock and roll because it's 12:32. I've got the syllabus up here to remind us what is on tap for the rest of the next few weeks. Homework 2 is due Monday. That is of the online variety. So using the online homework system to examine time varying predictors in univariate settings. We'll continue talking about the SEM translation of our models, and then project outline is the next thing that's due. So this is here to be downloaded. If you are working with a partner, only one of you needs to submit it, but I expect you to be working on it together to answer all the questions and such. Did I open a spot in Icon? If I haven't done that, I will do so. I think I did. Hopefully I remember to do that. Yeah, please check to see if there's a spot for it to submit on Icon. I thought I had done that, but who knows?
Nope, not yet.
Not yet. Okay, well, that will be forthcoming. And if there is any ambiguity remaining in my head about what I would want from you or expect you to do, you have a chance to revise that and turn it back in. That deadline is after break. So once I get outlines back from everybody, I will build the rubric by which you can see what I expect for your presentations. I want to make sure that it's general enough that it covers all the different things that folks are working on. Let's see. Yeah, we're almost at spring break, folks. 2 more weeks, and then we get a breather. I know, it's not too early to get excited, but it's coming. All right, let's see then. We were talking about some new stuff at the end of last time, the translation of these models into different types of ways of estimating them. That sound familiar? Give or take? So I am on slide 5 in lecture 4. We can pick up there. Maybe before there. Yeah, let's go back a little bit further. I changed my mind. Not re-go over, but review. Slide 2 instead. So setting up in terms of what people would call analysis frameworks, that's a word that you'll hear, or approaches or strategies. That often means some combination of model choice and software choice and estimator choice. So we've been working within one framework, so to speak, for estimating longitudinal models, which is as multi-level models in what I'm now going to call a univariate framework, meaning the software predicts one column at the same time. And that's all it can do. So we can trick that software into doing more than one outcome, but it's very limited in terms of what you can then do. The biggest problem is the way that time-varying predictors are addressed within univariate software. So we've been building like a person mean and a within-person deviation to be able to pull apart what is between-person variation in the predictor from within person. And using observed variables like that is suboptimal in a lot of cases relative to letting the model do it as latent variables, like it does for the outcome. So that's the switch in concept, is that everything becomes an outcome in a multivariate model, even if it's not actually being predicted by anything. At a very minimum, it would be an empty model predicting it so that you end up with the different piles of variance at each level that the predictors need. So when would you need a multivariate model beyond that? A couple instances to allow an outcomes variance components to serve as predictors of another thing. So like what we've been doing with time invariant predictors is saying, how does the random intercept change as a function of that predictor? How do the random slopes change as a function of that predictor? But the intercepts and slopes are always outcomes conceptually. If you're interested in treating them as predictors, then you need a multivariate approach. So the example that I had given was some kind of process where you're measuring change during a limited period of time, and you want to see how changes during that period of time then predict some other distal outcome. So like changes in how, let's say, how fast you grow in reading during elementary school, eventually predicting whether or not you graduate high school or something like that. To do that, the intercepts and slopes of your reading growth during elementary school need to become predictors of some other outcome. So that would need a multivariate model to do that in that order. To examine time-varying outcomes relations with predictors that also have individual differences in change. So this is one where it's not just suboptimal, but dare I say wrong, to use person mean centering if your predictor itself changes over time. The reason is that If you have person mean centering, we're essentially representing the intercept and the residual with observed variables. There's no way to make an observed version of the slope. If you output slopes from individual regression models and treat those as observed variables, it doesn't work. It doesn't work very well. That's what people did in the 70s before multi-level models were a thing, and that is an approach called slopes as outcomes that you will still occasionally see in different places, but it doesn't work very well. Another reason would be missing data. So if you are creating a predictor as an outcome by fitting an empty model for it at a minimum, then you can have incomplete cases. But you do so while assuming something about its distribution, usually multivariate normal. That matters more to the extent that you have more missing data. And then last but not least, changes in latent variables themselves. So if you want to build a measurement model to examine some kind of trait that's being indicated by observed outcomes, you can then watch that trait grow over time in these models as well. So lots of examples. Basically anything on this page would be a good topic for a project. So looking at how slopes and intercepts are related across outcomes in a multivariate model, doing anything that involves change in a latent variable would be one as well. If you're not sure what you want to do, come talk to me. I'm happy to chat with you and give you some ideas. I usually have more ideas than I know what to do with. So I can come up with 3 projects for you if you want. Okay, so we're reorienting ourselves here then. So multivariate is the key idea. We're predicting more than one longitudinal outcome at the same time. To do so, we have MSEM, as it is going to be called, multi-level structural equation modeling, or we have just regular flavor SEM. And people call it this even though there's no latent variables in it, because technically speaking, the random effects are latent variables. So that's why that terminology gets used, even if there's no measurement model being used in a traditional latent variable kind of way. So these are actually really similar to what you already know how to do in structure and in the way that you would implement things. They require long format data. That has certain advantages for it, especially with unbalanced time, because you still have a column in your data set with exactly when everyone was measured. You don't have to pretend that it's even interval or common denominator kind of time, that kind of thing. SEM is a different animal. So the biggest difference is the format of the data. It is wide format. So it's 1 row per person in SEM software. That then changes a whole lot about how the model is specified and eventually interpreted. And if you have unbalanced time, you need an option called a definition variable that is available in only certain software packages. M+ is, I know, one for sure. OpenMX is another one. So NM+ is what we're doing these for, because the other software packages are much more limited. We're going to look at the output for models you already know so far. That's what we're doing right now. So the new translation is just how do I think about this in this multivariate world, and how do I get to know the software that I need to do these things. So I have some notes here about how the syntax is going to be organized within the model section. So let me actually open up an M+ file so I can show you a little more directly what they look like. Let's go with, this is an output file. It's just a text file in M+, but I can make it big. So at the top of the output is the input that you put, so this whole piece right here. So M+ is one of those programs where you don't have just like a long syntax file and you can highlight pieces of it and run it. You have one entire file that gets run as an entirety. So you have to either comment out models you don't currently want or have separate files for every single model. So that's why if you look inside the download folder for the examples that go with this for 4A, move this over here so you can see it, I have a whole bunch of files and a whole bunch of outputs. So it's very, very easy to get into what we call file hell. Because of this, you have to be very diligent about naming things and not writing over them and that kind of stuff. I am told that the package M+ automation, it's an R package, can make this process less painful. The only catch is that to use it, M+ and R have to be installed on the same device. So if you're using M+ on the virtual desktop and R on your local machine, then that won't work, unfortunately. So for now, we're stuck in file hell. Yes, you could use R on the virtual desktop. In my experience, it runs so slow that it's painful. But If you had to, right, you could
Good
do,
to know.
yeah. You need to like plan to sit there and wait a while. You know, it's
Okay.
one of those like let it run overnight and come back and check on it kinds of things. But anywho, I will go over the code in more detail, but the part that I'm focusing on right now is like there's a section called model where you describe what you want in your model. And in multi-level model land, there's a separate within model and a separate between model. And what we will see is that this maps almost directly onto level 1 and level 2 equations using hierarchical notation. So if you're comfortable with those equations, it's just a question of implementing them within this framework. So that is what this part refers to. The other thing that's tricky is that there's different labels as a function of whether you're talking about a variable that is being predicted or not, even if it's in the model as an outcome. That distinction doesn't matter. So unpredicted things will have parameters called means and variances. Predicted things will have parameters called intercepts and residual variances. That gets tricky in terms of you're used to thinking about an intercept as like there's only one, right? We have an intercept. No, every term can potentially have an intercept because that just means conditional mean. So there'll be lots of them to sort through. Likewise, residual variances in this way of talking about it mean left over, not level 1 variance specifically. So you have to get used to that. And then where we put the slopes is in different spots for level 1 versus level 2 things. So you'll see lots of examples of this. Then we got to picture time. So how are we doing so far, folks? Okay so far? Enough? Any questions on anything thus far or comments? By the way, if you haven't done so, please check to make sure that you have access to M+ in the virtual desktop. I submitted a request earlier in the semester to IT for everybody to have access, so just making sure that, that you have it. If you haven't been in a class that's used it before, if you have, you should already still have it. I think they leave it in there. And
It's listed on my virtual desktop.
Okay.
I'm launching it now just to make sure.
Cool. If you didn't have access, it wouldn't be listed.
Right.
They just like, they cut it down. The license that we have is supposed to allow for 20 concurrent users of it. But I have never once in 5 years heard anyone complain. So I don't know if that means there's not 20 people on it at the same time, or it isn't working that way.
The day before our homework is
I was gonna
due.
say, yeah.
We're gonna max it out.
The good news is that there's only 13 of you in this class.
Oh, thank God.
Yeah, but I'm pretty sure like in the SEM class when homework is due and I have 30 people that we would have hit the 20-person limit, you know, around 10 o'clock that night when it's due.
Yeah.
But I never heard about it if it happens, let's put it that way. So, also, if you have research money from anything, like if you win any awards or you have like grant funding of some kind and you have money that you need to spend, M+ would be a good thing to buy because it is much less expensive if you purchase it as a student license than as a faculty license. Like the big licenses cost $900 and it's $175 a year to renew it. And this is why people are like, but R is free. Yeah, R does a lot of wonderful things, but M+ is continually being updated with the newest, shiniest, funnest stuff. So it's where people go to implement model developments. All right, so picture time, pictures and equations, mapping, okay. So happy little unconditional random linear time model right here. So I have the multi-level version and then the composite version. A corresponding multi-level SEM diagram would look like this. So as I said before, the entire world has agreed to diagramming conventions. It's one of the few things that are almost like always done the same way. We have boxes. Those are observed variables in your data set. So these are columns, and this is stacked data, by the way. So that's why I have level 1 Y. That's as many Ys as a person would have, and corresponding level 1 time as the predictor. Y has been partitioned into intercept variance and residual variance. So this circle here is beta 0. That's what it means. So this is a latent variable whose mean is the fixed intercept and whose variance is the random intercept variance. So I'm mapping the parameters that are being estimated in this model here. So note that U0 is an individual specific intercept value. What the model parameter is that's being estimated when you do it this way or this way is the random intercept variance across people. So this will be a number that shows up on your output the same as it does in Elmer or mixed. Then random slope is a second latent variable, so this circle is beta 1, and its mean, I know that's a weird way to think about it, but if you think about the fixed slope as the average slope, then gamma 1, is the mean of this variable, and its variance is the random linear slope variance. And it is tied to this line right here to indicate that it is this slope that this circle is describing. So beta 1, if it were just a fixed effect, like there would just be a coefficient on this labeling it, but because it's a random effect, it gets its whole nother circle where the mean is the fixed slope and the variance around it is the random linear slope variance. Two-headed arrow here is for the covariance between the two. And then level 1 residual down here has one variance to it, and within this software, there's really no way to change that. So like there's not an easy way to say, I want a different variance at time 1 than at time 2 than at time 3, the way that you can in customizing an R matrix to be heterogeneous within Elmer software, or not Elmer, it'd be GLS or Stata Mixed or SAS Mixed, things like that. So otherwise, because it's long format data, it follows fairly directly in terms of how the mapping happens here. So this is why I say that MSEM as a name is sort of overkill, because there's no measurement model hill. People would still call it multi-level structural equation modeling, even though it's only just multi-level. It's a multi-level path model is what I would call it. But then people like Chris Preacher would argue with me and say, no, these are latent variables, hypothetically speaking. Okay, with me so far? Cool. So then corresponding M+ code that goes with this diagram, and we'll look at more examples of that in just a second. When you list a variable by itself, you are referring to either its variance, if it is unpredicted, or its residual variance, meaning leftover variance if it is predicted. And it knows that. It knows which one it should be based on the context of the rest of the model. So when I say Y, because that's my generic outcome, I'm saying I would like a level 1 residual variance, please, and it would be normally stored in the R matrix on the diagonal. Y on time. The word on is a regression slope. Think of it as an equal sign if you were writing code to estimate a regression model. So it would be like Y equals and then predictors. That's the only way I can get the direction right, because I always think of it as this is the effect of X on Y. But to write it correctly, you have to write Y on X. So if you think of on as an equal sign, that will fix it. Other folks, when they teach regression, say, I'm going to regress Y on X. And I never, ever say it that way because it always sounds backwards to me. So, but that's what that means. The bar then is saying, I am going to give this slope of time predicting Y the name lin, stands for linear. You can name it whatever you like, so long as it is 8 characters or fewer. Yep, it still has that restriction from like the 1970s. So then lin is now a new variable. So I'm referring to this circle, essentially, by the name lin in the code. So that means that when you see lin by itself here with Y, we're estimating variances, but now we're in the between model. So this is going to be random intercept variance for Y, and lin, that's random slope variance for the effect of time on Y. Yeah, go ahead. Did you have a question? No, okay. Just an accidental unmute, no worries. Does anyone have questions? Not yet?
Can you just say that last thing with the between one more time?
Yep. So in the between model, that's our level 2 model. So when we ask for variances to be estimated, those are then random effect variances because we're in the between level. So Y here is referring to its random intercept variance in the between level. Y here is referring to its level 1 variance at the within level. So 2 different kinds. The covariance between the intercept and the slope is accomplished by the last line, with. So with means covariance. It would translate into correlation in a standardized solution, meaning after all the variables have been standardized to mean 0, variance 1. So with means covariance, on means slope. There's only one more word you have to learn, and that word is by. And that creates factor loadings, but we're not there yet. It is, it's an interesting language. I've heard many different people joke that the people who made this, the mutanes are their name, they don't like to type. So they created like this system that involves as less typing as humanly possible. But the net result of that is that if you don't know this code, you have no idea what's happening. Like it's completely untransparent. So this is me being nice to you, okay? Exclamation points in M+ create comments. So all of my code is very heavily annotated to explain exactly what that line is trying to do. The other part of it that makes this unnecessarily confusing is that there are a bunch of defaults that are invoked, and their code is even shorter because they're relying on the defaults. As an example, y having its variance estimated at both levels is a default. I didn't have to write that. Not a default, the covariance. I did have to write that. However, in the SEM side, it is a default instead. The brackety things here, those are used to request means if your variable is unpredicted or intercepts if it's predicted. Those are defaults. If you build this placeholder for beta 1 here, it gets a variance by default too. Now, I can tell from the looks of some of your faces that you're not happy with this, and I do not blame you, because it is annoying to have to memorize defaults, and it means your code may not be backwards compatible if they change what the defaults are moving forwards, right? Like, oh shit, yeah. So, for that reason, I type everything. Then I know what I have, and I shut things off explicitly that I don't want, even if that is a default that they're shut off. So you'll see some of that as well. So I will help you. The fact that this is such terse code helps me keep a job. That's the way I look at it. How about quadratic? Could we do a random quadratic model? Sure we can. So I have a third beta now that shows up as a level 2 equation. That means I have a third circle. One circle for each beta. That's how this works. I put it over here because I ran out of room on this side. So I have time squared as a new column. That would be an observed variable that you would have to create, by the way. You can't define interaction terms at the same level as on the fly. You have to physically build the variable. And beta 2 then is the name of this circle. It has a placeholder beta 2 on the line saying that this circle refers to the slope of time squared in predicting y. So now we have the mean of this variable is the fixed quadratic slope. The variance around that is the random quadratic variance. So this is why when I said before that having everything called a mean or an intercept makes it tricky, because you're going to see 3 things listed under means, but you're thinking of them as slopes. That's the way that the connection is made. Fixed effects are the means of the random variables. Variances are the random variances. And this, by the way, this technique, this is me cheating. This means all possible covariances among these 3 circles are being estimated. Otherwise, I'd have to draw 3 different arrows. So if you have a whole bunch of covariances to put in, I often cheat it by doing this kind of thing and put it in the note. It cleans up the picture. Here's what the code would look like to accomplish this model. Now I have a second placeholder variable called qua, and this is me being, me. I call it qua instead of quad so that everything stays aligned in the code. I name my variables with the same number of characters on purpose, so it's all nice and tidy. So it's qua and Lynn. They're like my friends. You're like, oh, that's pretty deep cut, Lise. I know, I'm of that kind. Your code is easier to read and troubleshoot when it's aligned. Then you can easily see if you have a typo or if you missed something, it just makes it easier. So I have time and I have time squared. So the regression of time squared predicting y is named qua. So now qua gets a mean, qua gets a variance, and then I have all possible covariances on one with here by listing all of them before and after. That does all possible. So then you don't have to type out all 3 of them. Okay. Do you want to see how the accelerated time models would look under this? Get used to this? Maybe? Maybe?
I have a question.
Yeah, hit me.
So where is y?
Where is y?
Like, is y the box for L1 and the circle for L2? Like, I guess I'm trying to like map on the code to the thing.
Yes, great
Does that make
question.
sense?
Yes, yes, it does. I think so anyway. I'll try to answer it, and then if I don't, then it didn't make sense. And then you can re-ask. So y is here in the picture, like the observed variable column, and y is here in the equation. In the code, what we are referring to as y at level 1 is actually the E circle. That's what y means at level 1 is this E circle here. What y means at level 2 is the beta 0 circle up here. Does that help?
Yes. Yeah.
Okay.
Because we partitioned it
Yes,
into these two imaginary pieces.
that's right.
Imaginary in the sense of like not absurd.
Exactly. Latent, imaginary, pretend things. That's what we have. So we have y at level 1, you're talking about E. That's what you're talking about. Y at level 2, you're talking about the random intercept instead. So what I was going to say is up to this point, if this were all I needed to do, there would be no reason to do it in MSIM. None whatsoever. Other than just to prove that I could as an academic exercise. Same is true of this slide, so I'll do 2 more slides and then we'll look at the example. I think it'll go better if I explain this first. What if I have a time invariant predictor at level 2 that I want to put in as a moderator? I could do that, right? L2x is what I'm calling it. So that could be either a purely time invariant predictor that's a thing that was measured only once, or it could be like the person mean of something that was measured repeatedly. That distinction is irrelevant in this context. Where these terms show up then is this box right here predicting each of the circles. And I have the corresponding fixed effects labeling each of the slopes. So the main effect of level 2x predicting beta 0 would be this slope right here, its effect on the intercept, bumping it up or down. The interaction of level 2x with linear time is gamma 1, 1. That would be this path. And then the interaction of level 2x with quadratic time would be the last one right here, gamma 2, 1. Still no reason to do it this way. None. You're like, okay, why are we doing it this way? Here's how the code would change. 1 line at the bottom. That made you happy. It did. Oh, thank God, just 1 more line of code, because you're layering these things up. So our friend on again, what does on mean? Equal sign. Yeah, so we are stacking up 3 regression equations in 1 line of code here. Level 2x is predicting y, linear, or lin and qua, meaning level 2x is predicting y, that's the effect on the intercept. Level 2x predicting lin is the cross-level interaction between level 2x and time, that's gamma 1, 1. And then level 2x predicting qua is the cross-level interaction of time squared in level 2x, gamma 2, 1. And if I had a second level 2 predictor, I could throw that next to level 2x, and then I would be setting up 6 equations with 1 line of code. So I like that part. I'm down with that. Now that things are being predicted, though, we're changing our terminology, and it will change in the output, which is why I'm alerting you to this. So let me go back up. Before we had mean and variance, because each of these beta circles is unpredicted. It's just sort of floating out there. Now we have intercept and residual variance, because they're being predicted. So how many intercepts do we have in this picture? We have 3. We have the one that you think it should be, like the intercept is right here, but then we have what is the expected time slope conditional on level 2x? What is the expected quadratic time slope conditional on level 2x? So from that perspective, if we look at these beta equations, the fixed effects here are like the intercept of that regression equation at level 2, and u is like the residual of it. So that's why they call it that way. If we just look at this equation right here, the jumping off point is the intercept, and I'm doing air quotes. But this jumping off point is the fixed intercept. This is the fixed linear time slope, the intercept of the beta 1 equation. This is the fixed quadratic time slope, the intercept of the beta 2 equation. So we have 3 intercepts now. Likewise, we have 4 residual variances in total, because we have one at level 1, that's this thing right here still, and now we have the leftover parts of the intercept, linear time slope, and quadratic time slope, the things that are unrelated to level 2x that are left over. Why do people still need their own, even after we gave them their own version through this predictor? So they're left over, that's what residual means. Okay, any of that you want to hear again or differently? Okay, I said still no reason to do it, right? Still, you did not need this in your life. Until this. What changed? It's very subtle. 1, 2. 1, 2. The arrows. The arrows are going the other way. So that is a different animal. We can't do this in Elmer or mixed. This is why you need this in your life. So now what I'm saying is that level 2x is an outcome. Like this is whether or not you graduated high school, and now my growth model is how you did in elementary school growing and reading or something. That's the type of context this would be. This might be an end of grade assessment predicted by changes in reading fluency during the term or something like that. So I attempted to notate this as best I could. Question?
Question about the means equals intercept, is that back to?
We're back to means and variances because these things are unpredicted. They are now the predictors of level 2x.
Got it.
Yep, so they're unconditional, they're not left over.
Great.
Yep. Yep. So I had to add to this, level 2x is being predicted by, and then I made up some stuff. Because level 2x is an outcome. So it has an intercept that's going to be estimated. The intercept would be the expected value of x when all 3 of these are 0. So then I would have a regression slope for beta 0 predicting level 2x, a regression slope for beta 1, and a regression slope for beta 2. And I would have some kind of x variance left over that is unpredicted by these things, which if I'm following consistent notation would be some kind of u. That's my best guess for the notation for this. In these models, it's usually described with matrix equations that you can't actually tell what's in them, and I find that terribly unhelpful, so I'm not going to do that.
So level 2x is the time invariant.
Yes, it's a time invariant outcome now. It's another variable that you measured one time for somebody. Yep. So here's what the code would look like. Very similar, but note the direction has switched. So now it is level 2x equals y ln qua, because those are the predictors of level 2x as the outcome in this picture. We would then have level 2x get an intercept for the predicted value when those variables are 0, and it would have a leftover variance at level 2 in the between model as well. So this is your first example of when you would need to do it in an MSEN multivariate framework. The reason is because y is an outcome and level 2x is an outcome. Previously, if I back up and go the other way, y is the only outcome in this picture. It's a univariate model. Don't like that? I'm responding to faces. This is why it's helpful to see faces, because then I can see the what reaction. That tells me to stop talking and ask for questions.
I think it's just gonna have
gonna marinate.
confused
Yep.
as to why we need level 2x in there. It's not predicting why.
So in this picture, we're back to the x is a predictor version, okay? So I backed up 2 slides. This is a predictor. Time is a predictor. Time squared is a predictor. Y is the only outcome. Y is in 4 pieces right now in terms of like where its variance is allocated to. I have 3 random effects at level 2 and 1 residual at level 1. But Y is the only outcome in this picture. So it's a univariate model in terms of like stacked data, 1 column. If I flip it so that level 2x is an outcome, now this is an outcome and y is an outcome. And 3 of the pieces of y get to predict level 2x. Could I have the 4th one predict level 2x? What do we think? Could I have level 1e have a line up here? Yeah, no. E is why are you off your line today? Today has nothing to do with eventually what will happen to you, right? It has to be something that's constant to you that would predict what will eventually happen to you. In regular SEM, that is not the case. So that's where smushing runs rampant in SEM versions of it because the levels are not clearly delineated and it's very easy to go across things that don't make sense. We're not there yet, though. That's just foreshadowing. So the equation then is level 2x as the outcome in this picture being predicted by 3 of the pieces of y, the intercept, the linear slope, and the quadratic slope. Okay, not that yet. So we'll marinate. I like that word. Another one I use for this is percolate, like coffee. It just needs to kind of like sit there and churn. Soak, yep. Percolate, marinate, soak. I like those. Okay, so this is the same handout we went through last week on Zoom, I think. I feel like I haven't been here in a while.
Yeah.
Get that feeling?
Yes.
Yeah. Yes, it went faster than I expected. I remember that. We were on Zoom. But this is the exact same set of models, and I have the code repeated in here for reference. So what we're going to do is walk through them from the perspective of we're going to do MSEM first and ignore the SEM side, and then we'll walk back through and do the SEM side. Because going back and forth is going to be too hard. So the story, again, recall is the outcome. We're predicting recall over up to 5 occasions in very, very old people, measured every 2 years. Empty means random intercept model, first off. Nice and familiar, right? We got that. So in Stata, we would do mixed like that, probably ask for an interclass correlation along with it, and let me put that in there. And do it later. In R, we would do the usual things, ICC and Renova to test it. Here is the R output so that we can watch the numbers match. One thing I want to note is that M+, like Stata, provides log likelihood by default. So if you need -2 log likelihood, you have to do that computation yourself. M+ also, to the best of my knowledge, does not have anything built into it that does likelihood ratio tests for you. You have to get out your Excel calculator, or M+ automation will send output back and forth, and then you can use Renova or ANOVA and stuff like that for R. So it does, the M+ automation essentially helps you build syntax, send it to M+ to run, takes the output, and then carves it up into R objects that you can do stuff to. That's what it does. So it's very convenient for that. I also have programs that I've written in SAS to automate M+. I built my own, essentially. So you can control M+ from other packages, which is really useful when you're running simulations or things when you need to, like, update a lot of stuff. Okay, so the interclass correlation for recall was 0.67. Now let's find that stuff in M+. So I've pasted in the entire input file that you would need. You would then run that file, and a new output file with the same name would pop up, and it's .out. One nice thing about the M+ files, these are all just text files. So input, the syntax part, is INP. You can open that with any kind of text browser. Like I use TextPad, WordPad, Notepad, any of that kind of stuff. The same is true of the output. It's just straight text. So out files can be opened in anything. You don't necessarily need to have M+ open to see your files. One thing that is annoying, though, is that this is what the data set will need to look like to read it in. I'm using a CSV file because it's easier than to open and see. Do you notice something interesting about my data file? There's no words in it. There's no labels. Hate. So you have to take the labels out. It will yell at you. And the way it yells at you is not a helpful error message, but I've seen it so many times that I know what it means. It'll say something about unreadable character at spot this, and it means words. How dare you put words into my algorithm? So CSV or text files is what you have to import. Text files are what come back. So it's very funny to me that M+ is probably one of the most modern analytic packages with respect to quantitative methods, but it's built using like 1975 technology. You have to input text data that don't have labels. You have to have text output. They have some graphics, but it's not great. And 8 characters or fewer for all your names and labels.
So when you label things, like, you just essentially have to keep track of that and then label it pretty much as soon as you load your data in, so you know.
Yeah, what I typically do is export my data set into Excel, grab the first row, copy and paste it into M+. Because what's going to happen is one of the very first things you'll tell it is what your data set is, and then the names option is what the column should be called. So you can just paste that out of Excel into this spot right here.
Okay.
It might be spaced weird, but otherwise it will work.
Yeah.
A few catches though. These names have to be 8 characters or fewer. It doesn't know what they used to be called though. So like you don't have to rename your variables in your original file because the names aren't coming with them.
Got it.
So you can shorten them relative to what you called them before. The other thing is that each of these needs to be 8 characters or fewer, I said that, and in the output, these lines can only go to 90 characters across. It stops reading after that point. So if you have text that extends past that, it will stop reading and give you an error message, but that can very much change what you're asking it to do. So those are some weird, antiquated constraints that you will get used to very quickly. Okay, things that are in blue capital letters are dedicated M+ commands. It will look for these. M+ is otherwise not case and space sensitive, but my coding convention when I am allowed is to put dedicated program commands in capital letters and anything that I would change in some kind of title case or lowercase. That's just my own convention. Comments are the green things. Exclamation point is the comment thing. And note there's semicolons as far as the eye can see. Everywhere here, everything ends in a semicolon. It's like SAS up in here. I saw a joke one time that SAS stands for, seriously, a semicolon? I thought that was appropriate. So don't forget your semicolons or it will yell at you, or do something stupid instead of what you wanted, because it will be confused as to where your command stopped. So all commands get terminated with a semicolon. Title is the first one, it's optional. All that does is print in your output, like what the model is. So that's just for you. I use titles to keep myself organized and looking at it. So like this is what my model is titled here. File equals CSV or TXT formats, or actually not TXT, .dat is what it needs to be. It's still a text file. If your syntax, meaning the input, is in the same place as the data, you don't have to say where this is. If it's in a different spot, then you need to put the full path to where the file is. In the virtual desktop, Some of you will need to put the full path in and some of you won't.
So if we get an error, like
Yep.
that's a good first place to start.
I've been teaching with M+ here for 5 years, and it has happened every single semester without fail that some people need to put the file paths in and some people don't. And I don't know why.
I'll also add, sometimes if it doesn't run, put it in your H drive.
Yes, if it doesn't run, it may be that the file path name has gone too long, if it's embedded in too many layers of folders. So if you put it in, I think the H drive is no longer a thing, but it's called OneDrive now, is that right?
Oh, okay.
There's both. Okay, there's both, all right. Someone told me last semester the H drive died, and I was like, what?
I think that was 10. And yes, actually, no, I remember that.
Okay.
It was 10. And it's because, like, we used to have to use, like, global file saves
Mhm.
in order to have the desktop, like, look for my OneDrive correctly, but now I don't have to do that. I can just do, like, the CD.
Okay,
So now you don't have to, like, do the extra steps to, like, signal to your virtual desktop that you need to go to the H drive. You
Oh,
just do
okay.
CD in your OneDrive.
gotcha, okay.
So send me OneDrive.
Okay, so use the H drive or the OneDrive would be the next if it breaks and doesn't run. And if that still doesn't work, then let me know and we'll try to solve the problem. Only some of you though, that's what I know. So because my data and my input are in the same spot, I can avoid that and just type that here. These are also defaults, but I have them in here in case you need to ever change them. Type equals individual. The alternative is type equals matrix as one. Like you can input a covariance matrix and do analysis on limited information that way. You can also do type equals imputation. So crossover with the missing data class. So multiple imputation is when you plug in the holes for your missing data with error, like repeatedly, like 100 times or something, so you have 100 data sets. What M+ wants is a name of a text file rather than a data file, and that text file lists the names of all the data files of your imputed model. So then you say type equals imputation, it reads that text file, runs the analysis on every file that's in that list, concatenates all the results, and aggregates them with Rubin's rules appropriately and spits out one output for the whole thing. It's glorious. So, pro tip, if you need to do anything imputation-y, it does make it pretty easy. And it will do multiple imputation and analysis simultaneously for certain combinations of things. But type equals individual is what I've got here. Format equals free, the alternative is fixed. I don't know if I'm probably dating myself, but like fixed format is when you have to tell it like this variable, it takes up 4 spots and this variable takes up 3 spots and there's a column in between. Try not to do that if humanly possible, that's annoying. So free format is like tab delimited or comma separated, that kind of thing. Variable then is the next section. So any questions before we do that one? We're good so far? All right. Variable then, names. This is where your variable names go in the order in which they appear. So this step is often reason why people get model non-convergence or terrible fit, is because they actually have more columns in their data than they have names, or vice versa, and their data are not read incorrectly, and everything goes badly from that point forward. So I used to have this problem a lot at Nebraska with students who used SPSS. And if you put, no hating on SPSS right now. It's a perfectly fine tool for a lot of things. It just doesn't grow very well. But anywho, when you filter a data set, like use only certain cases, in SPSS it adds a column to the end with the filter. So folks would do that, forget that the column was there, output their data for M+, but then it wouldn't read incorrectly because there was one more column that you didn't have a name for. So for this reason, I would highly recommend subsetting your data to just the columns you need for a given project. Make it as few as possible. I also, if you have any text string data, cut that out. Words are going to go badly. You can print descriptive statistics to make sure that your data are being read incorrectly, but there's no way to visualize them. So like in R, Stata, SPSS, and every other package on Earth, like there's a place you can double click and the data set will pop up and you can look at it. M+ doesn't have that. You just gotta hope that it's imported correctly. Hope and pray. Hope, pray, and percolate. All right. Use variable. Which column goes in my model? That's the question. So at this point, the only thing that's in my model, because it's going to be an empty model, is recall. If you forget this line, guess what happens?
Do you get it?
You don't get an error. Of course not. It'll run.
All of them?
It'll put all of them in there. The default is every variable in your data set goes in the model. And if you don't tell it what to do with the ones that aren't meant to be in the model, like person ID, it'll just make it like a box that's just floating out there, like in a path model of just open floaty boxes. And that's not going to go well. Person ID should not be a predictor or an outcome in most general cases. But no, it's not going to yell at you. It's just going to give you garbage.
I wish it would get it.
Lots of job security in the M+ environment here, if you can learn to fight with it successfully. But recall. Missing data. I am superstitious about this. I'm just going to level with you. Theoretically, you are allowed to have dots for missing data, but I have gotten problems with that being misinterpreted as decimal points, like and making things get all screwed up. So I deliberately fill in missing data values to any data set that's going into M+. I don't think you have to, but I just do it. So this tells it that every column, the missing data identifier is -999. All right, next are a set of options you probably haven't seen before if you haven't used multi-level modeling in M+. Cluster. That means what's your level 2 ID variable? It needs to know how the rows are organized. So person ID is being used in the code, it's not being used in the model. It's being used to group rows for the same person. Then there are options for between and within. These are empty right now because we don't have any predictors in our empty model, but what they are for is to delineate predictors that are available only on one level or the other, so that it doesn't try to split their variance into U's and E's as well. So we will see that in the next couple of models to come. Okay, any questions on any of that? And note semicolons, every line, everywhere. You don't have to have them in the comments, but you will find my comments have semicolons a lot of the time just out of habit, because you do in SAS, and I'm still proud SAS user. You can pry my SAS from my cold dead hands. I don't care if it's not cool anymore. It's vintage. How about that? Hey, if Target can bring back the clothes I was wearing in high school, I can keep SAS alive. Big nods, yep. Well, to be clear, I'm old enough that I was not part of that whole jeans that start well below your belly button trend. I was not part of that. I was slightly in the flared jeans era, where they were really long and they dragged on the ground and they got really dirty because of that. Jankos? I don't think so. Palmettos were my favorite kinds of jeans. That's like it was a knockoff Guess. It had like a little pretend triangle on the back that made it look sort of like Guess. Guess jeans were never going to be a possibility in my life, so I did the best I could. Anywho, analysis. This is where we're telling it aspects of what we want it to do. Some of this is default and some of this is not. Estimator equals ML. There is no such thing as REML. That's your only choice. There is MLR, which is robust maximum likelihood. That is used to correct fit statistics and standard errors for multivariate non-normality. I would normally default to that in what I do, but because I'm trying to get the results to exactly match what happens in Elmer and mixed, I am not, because they don't have MLR as an analog. Type equals 2-level tells it that it's a 2-level model. Can you guess what it would be if you were fitting a 3-level model? Yeah, type equals 3-level, spelled out like this. And random means that you're going to have random slopes. This model doesn't have them yet, but because I know that's coming, I'm just going to throw it in here and leave it. I think that's all that's in that section. Okay, and then we get into model. Within and between. So the level 1 model is described under, this is, what is that? Percent sign? Yeah, let's go. Where is it? I'm looking on my keyboards. Above the 5, that one. M plus has used every single special character on your number row. Yeah, they've gotten them all now. I've watched them slowly add more over the years, and I'm like, are they going to have to switch to wingdings at some point? Like to have, modeling options? Because they're going to run out of special characters. But we got within, we got between, no semicolons. And note that all the blue ones end in colons, not semicolons. Just for fun. Just because.
Could you remind me what the percent sign exactly denotes within M plus?
Nothing. It denotes a submodel.
Oh, okay.
Like it's organizing the models into layers. Kinda, yeah. I think you can think of that. There's a few other instances. In mixture models, you'll see these too as well. If you have like latent class models where you say, I want this in this class and this in this class, that actually throws in pound signs too, if memory serves. Just, because. So recall, that's my outcome. What I'm referring to is its E-variance. That's what I'm asking for. Recall at level 2 in the between model, inside the bracketes is the fixed intercept for recall. Outside is the variance. And you know how much of this I would have had to have typed? None of it. All of this would happen by default because I told it that I have recall in the model and because I didn't put it here or here, so it assumes that I want everything for recall on both levels. That's what it assumes. So I have not shown the rest of the output that's in here. Let's walk through an example file here. Don't ever try to print an M plus file. You will kill all the trees that are left on Earth at that point. So M plus starts with, when did you run the analysis? What version was it? I find that helpful because in papers you need to report this because it changes fast enough to where you would need to know that. It spits back all of your input. So that means when y'all are troubleshooting your projects, you don't need to send me input and output. All I need is output because it has the input at the top. One file. Then it tells me, hey, some of these people don't have any variation. Okay, I'm fine with that, but thanks for warning me. Then we get into how many groups, how many observations, how many IVs and DVs, and then we get into all the estimation things that you've chosen by default. So a lot of different convergence criteria, stuff like that. Observed versus expected information is relevant in computing the standard errors. Then we get into missing data, 207 people, what we have, on average 2.7 observations each. It does the intra-class correlation for me without asking. Nice. Then we get into missing data, what proportion of observations have values for all of these things. This is a different model, by the way. That's why I have time and time squared. Then we get into descriptive statistics, and then we finally get into the output, part that we care about. All right, get rid of that for a second. So I cut out all that crap because we don't need it. Yes.
If it says that they didn't come up with this, it didn't say model not converging, but it said something else like repeated solutions or something like that. What does that mean?
There's an error message about multiple starts. Is that what it is?
Probably.
That sounds right. That is, for certain kinds of analyses, it's possible that what it thought was the maximum likelihood is actually just like a hill on the way to the bigger mountain. It's called a local maximum. That happens in mixture models and things where label switching would be possible. Like for instance, if in a factor analysis, you could have the same result if the factors had negative loadings and positive loadings, because essentially the meaning of the trait would be backwards. So like in Bayesian models, like if it tries to find one and then it finds the other, like it might get stuck somewhere that's not the top. And so it tries to anticipate that that might be a problem and say, the solution to it is to run your model with multiple start values. That's an option that you can put in here. Like it'll do it 10 times starting at different places and see if it ends up at the same place. If it doesn't, then you worry. For most things, that will not be a problem. In this class of models, it won't be a problem. It's latent class mixture kind of stuff where that's a big deal. Okay, so then, this is all we get basically for fit. MSIM doesn't give you fit. It will give you AIC and BIC. I cut that out because we didn't need it, but this is log likelihood. And HO, that's the log likelihood of your model. What's normally provided in SEM software is the accompanying H1, which would be the log likelihood of the answer key. It doesn't do that for you in MSIM. So this is all we get. Model results, within level, between level. So it's organized in that way. Estimate, standard error, estimate over standard error, otherwise known as Z, and then p-value. And then me being nice to tell you what these things are. This is me, not it. If they did this, then I would not have a job. But they so could. Like, it's algorithmic. Once upon a time, Jonathan and I talked about writing a software package where that would be my contribution to it, is that I would algorithmically provide interpretations for things in the output, and we thought we would like win the world on that. So, someday.
I think you definitely would win the stats world.
Yeah, I'm going to win the world. Okay, within level variances for recall. So this is my level 1 residual variance. That's what this is. So 5.17, which is the same number that we found here, very close at least. Note that it gives you a hypothesis test for this variance. Do we use those? We do not. This is a Wald test for a variance, assuming a symmetric two-sided sampling distribution. The closer the variance gets to 0, the wronger that's going to be. So we would still do likelihood ratio tests to test new variances to the model, although when people use this software, you will usually see them cheat and just do it this way. A test statistic of 13 means, yeah, I'm pretty sure this isn't 0 in the first place. But it's residual variance, so we would expect it to not be 0. Between level variance for recall, what's that? What would I call that? Level 2, more specifically, yeah, this is random intercept variance. The mean for recall, what would I call that? Zoomers, you can play too. What is this thing? 9.7 is the number. I'll let you find it in the output. Yep, it's the fixed intercept that goes with the random intercept. That's what the mean of recall is. So it is the mean of the person means in this model, more specifically. Not going to be the aggregate mean of the sample because it's unbalanced data in terms of different observations contributing for each person. Some people have 5, some people only have 1. Okay, we're going to skip SIM. We're going to do the next one. This is a random intercept model that adds fixed quadratic time. So we're going to add 2 slopes. Here is the code and output that we're familiar with for reference. Here's the new code in M+. For clarity, I'm repeating all the stuff from before, but most of this hasn't changed. What has changed is in 2 spots. Right here, I'm now add time and time squared to the use variable line, and you do have to build time squared. There are, the option define in M+ allows you to make new variables, but I tend to do most of that in whatever package I'm using and then just export the data. Otherwise, it gets kind of annoying. I've also run into weird order of operations problems with it doing data transformations where it broke. So use variables goes there, and time squared go down here on the within
And
section.
then out to
Yep.
time.
Hit me.
So it's after the label, the variables that you've named. Like, does that create an issue, like in terms of the sequence, or it automatically knows how? Like, it automatically knows that time squared, when it sees it the first time, it goes down and figures it out. Does that make sense?
I'm not following yet.
So like, in my brain, when the computers are reading these files, they're reading it just like I would read it, starting at the top and then working its way down.
Ah, yes.
And we define time squared after we've already mentioned it up above as a variable.
Ah, so in this data set, I actually made it. I think. Is it time? Or did I? No, I did. Sorry. I did not. No wonder you're confused. I'm confused about what I did. I'm illustrating define. Yes. So it is backwards. It's not in the data. It doesn't exist yet. Still doesn't exist. Still doesn't exist. Now it exists. So it is not reading this in a linear fashion.
Okay. Cool.
And but the
Spanner would
requirement,
have a fit about that.
yeah. So it will have a fit if you don't list them after the variables that do exist. Like, you can't put time squared first and then recall in time. It doesn't like that. That's the only constraint. But yes, you're right that it is logically out of order, what is happening. So I did make time squared to show you how you could do that. So define is a way to make new variables. You can do things like cluster mean center using define, constant center. You can do lots of things. You can do recoding like if then. So if this, then make a new variable, that kind of stuff. So time squared is being created. Now it is being included in the model, and it is being included specifically only in the level 1 model. So it's not going to try to partition the variance in time and time squared into residual and intercept because of this, which is what I want. I'm treating these as observed predictors. So my within model then, here is the most direct way to enter them into the model. Recall on time squared. Because these are only fixed effects, this is fine. Recall has a fixed intercept here. It has a random intercept variance here. So because I put the slopes directly in the within model here, I didn't give them a name and then refer to it at level 2, they show up in the within model output correspondingly. So what would I call that? And feel free to read from the screen.
Slope of time, or I guess it's level 1, so it's probably a beta or no gamma. Predicting the beta. Fixed. Never mind, I'm gonna shut up.
No, you got all the words in there. It is a fixed slope. It is predicting beta 1, but beta 1 doesn't have any variance yet, so we don't need beta 1. We can just put it in the slope directly. We don't have to go through the convoluted beta notation system for this. So I'm illustrating different options for how you can specify these models and what they look like as a consequence. It is the fixed linear time slope. It is a simple slope because of the quadratic. So this is the rate of change specifically at time 0. And that rate of change becomes less positive, heading into negative territory by twice the quadratic per year in the study. So less positive by 0.1-ish or so. Residual variance at level 1 is this one. Means of recall at level 2, that is still the fixed intercept, and then this is still the random intercept variance right here. Okay, how are we doing? Percolating? Marinating? Yeah. Skipping SEM. Nah. Cross-level interactions, that's next, but I think that's going to wait till next week. Fair? I think so. All right, so big picture, why am I making you learn this? I think why is more important than how as a
And
place to
what
start.
specifically,
Yeah.
or because we're gonna have to use it.
You're gonna have to use it, yeah. Why is Elmer and mixed insufficient?
Yeah, smushing. You'll have a problem with smushing, and also you can use M plus to use outcomes as predictors.
So the use of person mean centering for time-varying predictors or cluster mean centering in cluster data if the predictor itself shows individual differences in change over time, then that needs to be in the model. There's no way to do that in Elmer and mixed. If you want your intercepts and slopes to be predictors of something else, you need to do it this way. If you have missing data concerns, you want to bring stuff into the likelihood so you don't have to delete cases. That would be another reason. And if you care about latent variables, right? This is supposed to be a program that focuses on measurement. What happened? This is a sum score, which sometimes I yell at people about, but not in this context. If I wanted to do a measurement model for recall from multiple indicators, then I would need to do it this way as well. So my guess is that most of you for your projects are going to end up in M+. That's my guess. Not required. And if you can find other software that does what you need, then that's fine too, but that's my guess. All right, any other questions you want to ask before we call it a week? Okay, then homework due Monday night. Let me know if you have any questions about that. And work on your outlines and let me know if you have any questions about that. Cool. All right, thanks for being here, folks. Bye for now.
Thank you.
My pleasure.